Okay, so for question 26 worth 3 marks. I'm not going to read out the question because we're basically looking at this diagram. Now, the question is calculate the efficiency of the drive mechanism. So, when we talk about efficiency, what are we talking about?
Velocity ratio. Mechanical advantage.
Okay, so efficiency is equal to which is bigger? Which one's going to be closer to 100%? Mechanical advantage or velocity ratio? Velocity ratio.
Mechanical advantage on velocity ratio.
Okay, so what I'm trying to get at here, the point I'm trying to make here is that velocity ratio is like perfect mechanical advantage. It's like the ideal version. It's the perfect 10, right? There's no blemishes, there's no little, it's the perfect 10. Whereas mechanical advantage is what we have in real life after we have to deal with friction and whatever else might cause us to lose efficiency. So, in this situation, can someone tell me what MA is equal to?
LMA.
Yep, so it's like the word male, M-A-L-E. Okay. In this case, what's the load and what's our effort?
72 for the load and 446 for the effort.
Okay, so that's a number less than 100%, yeah? Now, normally we expect mechanical advantage to give us an actual advantage, to give us an increase in load. But not the case with bikes. Yeah, bikes are one of the examples. What's the other example we talk about where we... Fishing rods, great. So we're going to get a mechanical advantage less than 1 because the whole idea of bikes, the advantage of bikes is that we have this drastically reduced amount of friction by using a bike. So we accept that loss of mechanical advantage because we're not doing tiny jumps in the air. Okay, can someone with a calculator tell me what that number is?
0.1614.
0.1614, thank you. Okay, now the velocity ratio, that's a little bit more difficult. Okay, so for the velocity ratio, the formula here is that we're going to write the two diameters, one diameter over the other diameter, plus the nrev. Can anyone tell me what nrev is?
It's large amount of teeth or the small amount of teeth.
Yeah, so conceptually what the nrev is the nrev is how many times is something turning, right? How many times is one wheel turning relative to the other wheel, right? So yes, what matters is the diameter of one wheel versus the other wheel, or the circumference of one wheel versus the other wheel, right? We like to use diameter because diameter is proportional to circumference, right? But we also need to take into account if one wheel is spinning much faster, that's also important in our velocity ratio. So in this case, I have here that we have 167. Where's 167?
Isn't it 168?
It's 168.
Sorry, 168. Why do I have 168?
That's the distance between the center and the load.
Okay, is that a diameter? I said we like to use diameters, right?
Yeah.
Is that a diameter?
No.
No, so in this subject we like to use diameters. That's a radius, so I'm going to multiply that number by 2. Okay, and then we also have, what's the other diameter we're comparing to? What's our other diameter we're comparing to?
675.
675 is the big diameter. Great. Okay. Now we also have to consider the velocity ratio, right? Which is how much one thing is turning versus the other thing. Okay. So our first wheel, right? Our wheel that's 168 in radius, which is going to be like 300 and something diameter. What was it?
Shouldn't that be 675? Yes.
Oh yeah, sure. Sorry. Yeah, I don't know. I'm getting my last digits all wrong. Yes, correct. Okay. Our wheel that's got the 168 radius, right? How many teeth does it have?
17. 49. Oh, the wait.
49. So we reverse that number. We put the 49 on the bottom. Okay. The 675. How many teeth does it have? 17. So we put it like that. Yeah, that's one way of writing out nrev, right? We're multiplying the thing by nrev. Now, there's alternate ways of doing this. I don't really mind. The book has ways of approaching it. Whatever helps you to remember is a way of putting these numbers together. Yeah?
17 over 40.
Because that's our nrev. That's how many times the thing is going to spin around. Yeah, so we can also multiply it by the nrev here. We can put 49 over 17.
Okay.
that's the same thing as writing it as multiplying there. Whichever way works for you, I don't care. Now, I've said to you before, this formula to me, it's not very intuitive and it's not very memorable. So I would suggest that this is one of two things that you should bother learning just prior to the exam. Do a couple of these the day before the exam just to keep it fresh so you remember which numbers go in the NREV. I wish I had a story or a joke or a meme or some other way of helping you to remember this. Unfortunately, you just got to know that how to work out NREV and how to get your numbers. Okay. So if we want to multiply by NREV, but I'm going to go with 17 over 49 times 17 over 49. And our number there is going to be 0.17 something. Can anyone give me the extra two digits?
For the efficiency?
Yeah. No, for velocity ratio.
Yeah, that's what I got.
Just
Yeah,
exactly?
I got 0.17.
I got 0.1727.
27, great. Now, this is, I'm usually pretty rough and ready with my rounding, yeah? As you may have learnt. But this is one case where you want to go to 4 decimal places, yeah? You really want to kick an extra notch. Okay, so then our efficiency is going to be 0.1614 divided by 0.1727. Now, efficiency can never be more than 100%. You can never have something that, well, okay, I'll stop there. There's one example where you can have something that has over 100% efficiency. I'll get back to that in a second. Sorry? Yeah. Okay, what is the percentage here? Anyone got it?
0.9345.
They just rip over the top of the word.
Okay, so 94% was the number I got, yeah?
Yeah.
Okay. Now, so 94% efficient. Now, I had someone here who got 97% and I was probably happy to keep that with rounding, as long as the working out looked okay. Wait, no I didn't. I'm looking at that here. Okay, so that one was I have to discuss with the person. Anyway, I'm going to move on. So, the example where you can have more than 100% efficiency, heat pumps. It's the only thing, right? Because heat pumps, usually where we're losing our energy is because we're losing it to heat. If the purpose of the thing is to make heat, then it's actually possible to get additional heat from outside the system and therefore be more than 100% efficient. But that's the only example that I'm aware of. Okay. The next question, question 27, is... I need to take a photo of this. This Q26. Let me quick tick. Okay. So the next question is a past HSC question as well. And I'm going to use, for the sake of the answers, I'm just going to show you the HSC answer. I think is probably the easiest way, especially in the case of this. So I have that open here. So what I was looking for when I was giving marks. Okay, first of all, one thing I have a problem with this HSC, and I think I talked about this when we went through we went through these drawings in the album, is that you need to see a clear differentiation between light and dark lines. Now that's hard for them to do on a scan, yeah, a PDF scan. But the marker wants to see that your section lines are lighter than your dark lines. Now your dark lines should only be things that are actually being cut through. If you're not cutting through it, if it's something in the background, or if it's a center line, or if it's sectioning, well actually sectioning should be thin, so center line should be thin dark lines. I take that back. But thick dark lines should only be things you're actually cutting through. Now, your section lines, they should be thin light lines. Now, that's the first thing. Is just as long as somewhere, it's my understanding for HSC marking, as long as I can see somewhere that you've differentiated your line types, I'm going to give you marks. Okay, the center lines were provided for you in the drawing. So no marks for that. The things you had to do, you had to show me sectioning, right? That's good. Now you had to show the sectioning going in different directions because we've got two different materials. That's good. You had to show me this threaded section. Yeah, you had to show me the threaded section here. Now, in the case of this drawing, they tell you that the bolt is an M15 times 2 bolt. If it's an M15 times 2 bolt, is it fine or coarse?
Fine.
Fine. So the depth of the thread is going to be, depth of the thread is half the pitch. Half the pitch, so it's going to be 1 millimeter. The thing is though, this is drawn at a 2:1 scale. Now, when I printed out this paper, I had to print out this drawing about 10 times over an A12 so that I could get this page so I could get the scale to be exactly 2:1. Right? I hope you appreciate all that effort I put in for you guys. Yeah, I'm sure you did, buddy. I'm sure. Anyway, so that's how the sectioning looks there. The sectioning of that thread. You have to section this thread here. Now, you need to also, something I took marks off for, is you need to be able to show the sectioning for the threads here. So where there's no bolt in the thread, we section. Where there is a bolt in the thread, we leave it blank. We leave it like this. Does that make sense? Do people understand what I'm saying there? Now I gave this was worth 6 marks, so let's go through it. One is just drawing this, did it say how far it's threaded into it? No. Yeah, it does. It says 8 millimeters deep. So I gave 1 mark for drawing this. I drew another mark for correctly drawing that sectioning. I drew so that's 2 marks. 3 marks for drawing this correctly here. So that's 3 marks. 4 marks for correctly drawing those 2 lines there. Now those 2 lines, you could calculate that, you could get these lines here, you could get those lines by drawing a hexagon up the top. That's what you're supposed to do, is you're supposed to actually draw the goddamn hexagon above. Yeah? But
That's insane.
it is insane. And you know what I tell you as a little trick to get away with it, is as long as those lines, as long as this line is between those 2 lines, I'm happy. Yeah? For me, for my money, I'm happy. As long as this, Sergey, what do you need to do as a bare minimum?
Clear differentiation between light and dark lines.
It's a good guess. Right? I commend you for taking a punt. You didn't know what to say, so you said something, and good work. But what I was saying is, what you're supposed to do, I'm going to move this over so that for you guys, you can see how you're supposed to draw this. Is what you're supposed to do is you're supposed to actually draw a circle, and then you're supposed to draw a hexagon that is, so you find out half, and you using your radius, you're supposed to do that, and then transfer those lines down here. That's what you're supposed to do. Yeah? But engineers, they're lazy. And markers are fairly generous. I'm saying that really quietly. The markers, from what I believe, are pretty generous. But anyway, now these lines, as long as they're between these lines, Sergey, this is for you. Come up here, mate. Come up. Yep. Everyone, can we get a round of applause for Sergey? Hey, Sergey! Okay. As long as this line is between these 2 lines, you're probably going to be happy. Yeah? Can you just tell that to everybody?
As long as that line's between the other 2, he's happy.
Yeah. Now it should be.
He's happy, sir.
It should be slightly to the edges.
You reckon he's happy?
Slightly to the edges. Slightly to the edges. Yeah. Okay. Slightly to the outside.
Yes.
But you know what? As long as it's between the 2, there's a fairly reasonable amount of tolerance. Yeah. Okay. Sergey, everybody. Sergey. He gave some really good advice for drawing online. I think you guys all saw that. That his pro tip was
really bad. 3 days in a row.
Okay.
No,
Okay.
Spitting in that fire.
So 1 mark, 2 marks, 3 marks, 4 marks, 5 marks, and what did I have as my 6th?
I don't know.
Thread depth.
Yeah, the thread depth on both. Okay. Line thickness was the 6 mark. So yeah, as long as yes, thank you. Yeah, so yeah, he was right. Can everyone say it? Okay. So if you look at the actual marking outline here, I mean, they don't really give you much to go on. I have actually seen how the markers do this. They have this huge sheet where everything is done in thirds of a mark, so they do ticks, and at the end, so they look at all these things, and at the end they divide them by 3, and that gives them the mark. But I might be able to find that. I might be able to find one of those sheets that I was given. They're given as overhead transparencies so that you can put them over the drawing. But for me, I'm a little bit more holistic, so I look at the bigger picture. Okay, moving along. Okay.
It's another friction
Question
question.
29. Now, question 29, this is exactly the boat question. And I got to say, a little worried. I thought, you know what, we've done this question so recently that I actually have to change the values in the question just to make sure that you guys don't just like remember that it was exactly what it was. Yeah? Because we did this right in the lead up to the exam. Okay. A 900 kilogram boat rests on a trailer inclined at a 22 at 20. It should be at not at A, but it should just be 20 degrees to the horizontal plane. The coefficient of friction is 0.2, and the winch cable is parallel to the trailer supports. Calculate the minimum force required in the winch cable to just prevent the boat from slipping. Okay. I'll just check that this question, it doesn't actually go on. It did in HSC, but I wrote a separate one just to make it easier. 3 marks. Okay, so what do we have to do for those 3 marks? Let's have a look. Okay. Now, first of all, which way does the boat want to go?
Down.
In this question, they're talking about they just want to stop the boat from slipping. Yeah? Yeah, we happy with that? They just want to stop the boat from slipping.
Yeah.
So, I'm going to start off with my simplified formula. Right? Do you guys remember mucus?
Yeah.
Do you want to add mucus or minus mucus?
What the hell is
Is it helping?
Okay.
Yeah, we
Stuff
add.
that comes up in the throat. Oh, thanks, man. Cheers for that. Yum. That's what it is. Ooh, pretty clever bitch.
Okay. So, what are we trying to do?
And the tension in the winch cable.
Okay, we're finding the tension in the winch cable. Are we trying to pull the boat up?
Yes.
We're just finding what we
Keep it still.
need
We're
to
just gonna
stop
keep
it from
still,
falling.
So friction is helping us.
Okay. So, if friction is helping us, are we going to have a bigger number or a smaller number?
Oh, smaller number. Actually.
Yeah? Friction is doing some of the work for us. If friction is doing some of the work for us, we can minus. Right? So in our case here, I'm going to write in here T equals mg sine okay, why? Because friction is doing some of the work.
Do you have to put mu in bracket, the stuff outside of mu in brackets because it's times something anyway?
What?
Okay.
It doesn't need to be in brackets because you're multiplying everything together anyway.
It's true, but I find it easier to remember.
Yeah.
Yeah?
Yeah.
How about, look, I could do it like this.
I don't mind.
Right? Just to help us keep everything together, right? Now, I'm trying to help you remember as mu cos, which is that always, I'll draw up our diagram. I'll draw up our actual forces here. So this is at 20 degrees. We've got our boat. Now, our boat wants to go downhill, but the friction says no, no, no. Yeah?
Oh, good.
We've got our normal reaction here. We've got our weight. Now, what forces do we have here? This is equal to, I'm going to write, instead of weight, I'm going to write mg. I'm trying to get in the habit of using mg instead of w.
There's also the cable that's holding it up.
Yeah, but that's the force that is, T is the thing that we're balancing here with, right? So mg, but it's the cos, it's the opposite and adjacent, yeah? So, sorry, cos because it's the opposite and hypotenuse. So if we look at this side here, it's adjacent. God, I've just said the wrong thing twice, and I'm thinking, well, I would edit that out, probably not. This side here is adjacent, yeah? Yeah, this side here is adjacent. Adjacent is cos. So I've got mg cos. Yeah? This angle up here is mg sine theta. Yeah? So what are our forces in the parallel direction? What are our forces? What have we got?
FF.
Okay, so let's set something as positive, right? We're setting up the slope as positive. We've got some of our forces in that direction, some of our forces in the x direction equals 0. 0 equals, what is our assumption for t? Which way do we think that t is going to go? You think it's going to be up? We're going to be pulling on it. Okay, so that's going to be positive t plus t. What do we got? Is our sine, is it going in our direction or not? No, so it's going minus mg sine theta, right? And what's our friction? Is it going in our direction? Yes. We're guessing. We're making assumptions, right? Assume. Yeah, we're assuming this one here is going up there. We're assuming that one's going down here. And our friction, we're assuming it's going to be positive, yeah? If our number is negative, we know that t, our assumption was incorrect. Yeah? Now, so, what we can then do is we're going to have, if we bring our t over to this side, we're going to get ff if we get this, take this to the other side, effectively what we do is this becomes, change both sides, we get our mg sine, and this, we change the sign for this one here as well, ff. Now, ff, how do we figure out what ff is? What's our formula for ff? Friction, come on, what's the fun formula? Mu n. The problem is we don't know what n is, do we?
9.
Well, we do. It's not equal to the weight. It's equal to the perpendicular aspect of the weight, which we said was adjacent to the angle, which is mg cos theta. Yeah. So we've got mu mg cos mg cos theta. Yeah? So do you see now why I put it in brackets? Do you see why because this part here is the perpendicular aspect of weight. Yeah? Because this comes from our n. Yeah? It's our n aspect. Right? So, if we then can rewrite this calculation, we can say t equals mg sine theta minus mu, because that's part of the friction formula, n, which we just said was mg cos theta. Which, if it helps you to remember, mu goes with cos, which sounds a bit like mucus. If that helps you to remember it, good for you, right? Now, friction can either help you or hurt you. If friction's working with you, you minus, right? Because you're going to do less work. If friction's working against you, which means you have to do more work, then you have to add. Yeah, so that's how we're going to approach this. Okay, what I'm really excited about is that Harry is going to have to do this in the front of the class in a second, which will be a lot of fun. Okay, so just to apply this, we'll see. We'll test that out. Okay, to apply that, what's our values? Okay, so what was the weight? What was the mass? Let's start there.
9,000.
Well, so it's 900 times 10.
9.8.
Times sine, what's our angle? Sine 20 is what?
Yeah.
Can someone type in sine 20? You know what, I'll just let you do the whole thing. Okay, mu, what was our value for mu?
0.2.
0.2 times 900 times 10 times cos 20 degrees. Now if I type that all into a calculator, I get 3 078 minus 1691, which if I type that all on the
1386.73.
okay.
Good job.
Now we'll pull off and get Harry to do it.
Oh no, we'll do it after we've gone through the whole thing, because that'll be one more edit that I have to do.
I think there's a lot of ways you can do that.
Look, the trick I think to these things is just not caring. Okay, now is this the last question?
Yeah.
Yeah, it is. Okay, so we've got 29B. Right? Ordinarily, if I wasn't recording, I'd probably be getting some Flavor Flav happening right about now. Right? But, it's a pretty easy question, right?
Hey, this was like I got to the end and I was like, oh, I've got another like 10-minute question to do, and then no, like 1 minute.
Great. Okay. So, well, you're given 3 minutes to do this, right? An electric motor drives the winch to pull a boat and trailer at a constant velocity of 3 kilometers per second. The power of the motor is 5 kilowatts. What is the resistance to motion of the winch?
That's 3 kilometers.
Okay, so what we're going to do is we're going to write data. Right, what are we given first? V equals 3 kilometers per hour, which straight away we're going to divide. What's our, it's going to be? Ed Sheeran says 3.6 divided by 3 divided by 3.6 equals what?
0.83.
0.83 meters per second, right? Now, we're also given our power. P equals 5 times 1,000 watts. Yeah? Now, unless you're someone who can't read the formula sheet, this would be where I'd be looking and saying, okay, what's the formula for power? Right? Now,
I cannot read that formula sheet.
okay.
Yeah, that's pretty age for it.
Okay. So, if you look at the formula sheet, you can see that it says P equals W divided by time, or it says P equals Fs over time, or because S over T is velocity, it's P equals Fv, right? Now that last part, the Fv, that wasn't on the formula sheet a couple of years ago. Now it is. But you guys shouldn't need that. You should be able to remember that when it comes to power, and you got to fight the power. Come on, let's do a little bit more enthusiasm. Come on, Harry. Come on, fight the power. Fight the power. Come on, let's one more time. Come on, Harry, you ready? Fight the power. Fight the power.
Come on.
Okay.
Oh,
Fight the power. Fight the power. Thank you! Yay! He'll be here all week, guys. Okay, so P equals FV. Yeah? P equals FV. So therefore, if I want to find the F, I'm going to write F equals P over V, which is going to equal 5,000 divided by 0.83 equals, what was that equal to? Yeah, 6,000 newtons. Yep, pretty good. Pretty good. Okay, 3 marks for that.
No, it's
Pretty easy.
That's 2 marks.
I mean, all you had to do is be able to decipher the formula sheet, and you're golden.
So
That's the hardest.
That's the hardest
So
part.
that's the 2 marks.
Oh, cool.
That's a 2 mark question.
Sorry, I tell a lie. That was a 2-mark question. Yeah, okay, that seems about right. I feel better about that. The 2 marks is where that should be. Okay.